Hello everyone. In this video, you will learn how the MicroBlaze processor handles multiple interrupts. You will be shown how to set up the block diagram in Vivado, followed by a real-time demonstration of multiple interrupts occurring on the MicroBlaze processor. So to start, let's explain how a single interrupt from a single button works. Once you understand how the process works for one button, we can explain how it would work for multiple buttons. First, you will press and release the button, which will produce a noisy signal. The noisy signal enters the Button Debouncer IP, which generates a clean, single-cycle pulse on the falling edge. The pulse enters the interrupt controller, which sends an interrupt signal to the MicroBlaze processor. Each time the processor receives an interrupt, it toggles the LED and prints the total interrupt count through UART. So before watching this video, I recommend watching the previous lesson, since that lesson shows you how to set up the block diagram. In this video, we will reuse that same block diagram. So to make the block diagram from the previous video go from supporting only one interrupt to supporting two interrupts, we need to make only two changes. The first change is that we must use two Button Debouncer IP blocks. The second change is that we must add in a Concat block. The Concat block is the only new IP block to add, since all other IP blocks were explained in the previous video. It takes in two inputs, IN0 and IN1. The output is a 2-bit signal that combines both inputs together. Input 0 gets assigned to bit 0 of the output, and input 1 gets assigned to bit 1 of the output. To set up the block diagram, open the block diagram from the previous video. Then add in another Button Debouncer IP block and add in the Concat block. Then make the connections and validate the design. After the design has been validated, add in the provided constraint file, generate a new HDL wrapper, and generate the bit stream. The bit stream generation failed. To find out why, let's look at the messages. The messages show that the constraint file was not handled properly. To fix this, go into Elaborated Design, select the I/O ports, then manually fix the voltage level settings for the two unassigned pins. After that, select the correct pin numbers for the two unassigned pins. You can get the pin numbers by looking at the constraint file. Then finally fix the constraint file to use the names used in our block diagram. Now regenerate the bitstream again. After the bitstream is generated, export the hardware to a known directory and program the device. Before launching the Vitis IDE, choose an empty folder for your project workspace. This is the folder that I will be using. After choosing the folder, launch the IDE. Create a new application project. Then navigate to the folder where you exported the hardware and select the XSA file. Give the project a name. And then create an empty application project. Next, create a new source file for the demonstration code. After creating the main source file, paste in the provided demonstration code from the project files. Then, click the hammer icon to build the project. After the project has been built, open the Vitis serial terminal and connect it to the board. Next, create a new run configuration. Uncheck Program FPGA, click Apply, and then run the application. The demonstration code will now be loaded onto the MicroBlaze system. After the code has been loaded, we can press and release either button to see whether the interrupt is working. Each time we press a button, the LED toggles and the interrupt count for that button is printed in the serial terminal. From this, we can clearly see that the project is working exactly as intended. Alright, so if you have made it this far into the video, you should now feel comfortable adding in multiple interrupts to any MicroBlaze project you have. While we used buttons in this video, the interrupts could have come from any other source. Alright, that's all for this video. Thanks for watching, and I look forward to seeing you in the next one.